pictures. All right, so here we go. Everybody's on page 10, number 4. And we are sketching this guy. Okay, so here we go. This is not hard at all. I want you to forget everything in the problem except right here. Y equals the absolute value of x. What does that look like? Y equals the absolute value of x. It's a v. So I'm going to go ahead and sketch my v. So there's my nice little absolute value v. Would everybody agree with that? But this is a piecewise function, which means I don't want the whole thing, I only want a piece of it. And the piece that I want starts where x is 3. So it starts right here. Now, what are the coordinates of that point? If I'm letting x be 3, what will y be? I put 3 in for x. What would y be? What's the absolute value of 3? 3. So this is the point 3, 3. It says, let x be 3. Actually, it says greater than 3, so I put an open circle there. Okay, now, do I want the left piece of my v, or do I want the right piece of my v? Look right here. What do you think? X is greater than 3. Do you think you want this piece, or do you think you want this piece? That one over there. So we're simply going to erase this. Now, those of you that are using pencil like you're supposed to, that's not a problem. If you're using pen, it's going to be a mess. Use a pencil. So this top line is the entire absolute value. I only want a piece of it, and the piece I want is the part that starts where x equals 3. And I want to be bigger than that, so I want the right side. Now I'm going to the second part of my problem. What does this look like? Y equals x squared. What shape is that? What's x squared? That's a u, a parabola. All right, so I'm going to go ahead and sketch my parabola. There's my parabola. That's x squared. That's what x squared looks like. It's the parabola. Now, I don't want the whole parabola. I only want a piece of it, and the piece I want starts where x equals 3. So here's where x equals 3. Here's my point. I'm going to color it in because it's or equal to.
Why is it so high up?
Well, what would the coordinates of that point be? If we put 3 in for x, what do we get for y? 9. That point's up there at 3, 9. Now, I want a piece of the parabola. Do I want the piece on the right side, or do I want the piece on the left side? This time I want the left because it says less than or equal to. That's why it's a closed dot. So I'm going to erase this part. I don't want that part. I only want all of this. So I have my picture done. It's a piece of the absolute value b, and it's a piece of the quadratic parabola. Let's try the next one. These are not confusing if you stay organized. Try to look at just one part at a time, and it's not too bad. Now this one has 3 pieces to it. here we go. Now, don't be overwhelmed. Forget everything except right here. Y equals x plus 1. That's what I'm going to graph first. I'm going to graph y equals x plus 1. What shape is that?
One.
Okay, let's take that off. What's y equals x? That's your identity, right? So if I stick a plus 1 on the end of it, what does that do? Up 1, pops it up 1, yeah. So I'm going to have this line right here. That's my identity lifted up 1. I don't want the whole thing though. I only want a piece of it. What piece do I want? The piece that starts at 0. So if x is 0, y is 1. How do I know that? Put 0 in here. It gives you 1. Y is at an open dot. Not included. Now I have to decide which piece of the line do I want. Do I want the left piece or the right piece? The left piece. So I'm going to erase the right piece. Piecewise function. I want a piece of each of these. Now my next equation is y equals 3. What does that look like? Y equals 3. Yeah, exactly. Thank you. That's exactly right. It is a horizontal line, kind of like our horizontal asymptotes we were talking about. At up 3, at y equals 3, up 3. This says y equals 3. I don't want that whole line though. I want the piece that starts where x is 2. So that would be right here where x is 2. Right? Now, do I want the left piece of that line or do I want the right piece of that line? Look right here. I want the right piece. So I'm going to get rid of all of that. Now the third equation, y equals x squared. That's a u, that's a parabola. So I'll go ahead and sketch in my parabola. But I don't want the whole parabola, do I? This one's tricky. What part of the parabola do I want? The part that starts at 0 and stops at 2? Remember, that would be the point 2, 4. Because if I put in 2, I get 4. So what piece of that do I want? What piece of that parabola do I want? The middle piece. I want the piece in between my 2 dots. This says look in between 0 and 2. Very good, Jonathan. Very strange looking picture. These often are. Okay, let's do one more. This one's back to just 2 pieces. Right? right, so here we go. What's the top one look like? What shape? What's that top one?
A line.
That's a line. And it's a regular line. That would be the identity, but it's been dropped down to. So it's going to look like that. That's supposed to be a straight line. Very straight. Do I want the whole thing? Well, no, I never want the whole thing. What part of it do I want? The part that starts at 0? So that would be the point right here. That's where x is 0. And I made it an open dot. Why'd I do that?
It's just greater.
Because it's not or equal to. And then Stato, I need to figure out whether I want this piece or that piece. Which piece do you think I want? The right. And why do I want the right? Greater than 0. Perfect. What's that? I know it's a 3x. What shape is it? Y equals 3x. What shape is that? Nothing squared or anything, which means it's a what? It's a line. And what do I know about that line? Its slope is 3. And what's its y-intercept? 0. So it starts at 0 and has a slope of 3. So that means up 3 over 1. It's supposed to be a straight line. I don't want the whole thing. What part of it do I want? Starting where? Where do I want to start?
Origin.
At the origin. Solid dot. And then I have to decide which piece I want to keep.
Bottom.
Less than, so I'm going to keep the bottom, get rid of the top. And there is your piecewise function. Little tricky. Yes, Megan.
Will they ever overlap?
Now, good question. Remember, these are piecewise functions. So they must pass the vertical line test. So whatever you end up with, you have to be able to draw vertical lines through them and only hit once. So like even this one, as weird and strange as it looks, when you pass vertical lines down through, you only hit each curve, and you only hit in one spot. So in terms of overlapping, never this way, because they have to pass the vertical line test. Great question. All right, we have 2 more topics to cover. We're going to get through at least one of them here today, and that is section 1.4. Which, by the way, means that 1.3 homework now could be completed, right? And we're going to start 1.4. So, these first few problems are super simple. Okay, so I just have three random functions, and I've named them F, G, and H. Nothing special, nothing to worry about, just to keep them separated. First question says, let's add f of x and g of x. Do not make this hard. It is completely common sense. What do you think f of x plus g of x will be? Yes! X squared plus x plus 2. I'll put it in descending order. we're just adding the g function and the f function together. That's all. It's that easy. Now, number 2. What do you think 2f of x would be? Again, don't make it hard. 2f of x. 2 times x plus 2, which is 2x plus 4. All right, how about this one? G of x minus h of x. Yep, watch your subtraction. It's going to be x squared minus negative 2x plus 5. That is g minus h. So we'll have to distribute. And we end up with x squared plus 2x minus 5. This is easy as can be. This is not difficult at all. Right? How about f of x times g of x?
X cubed plus 2x squared.
Yep, it's going to be x plus 2 times x squared. Distributing would be x cubed plus 2x squared, just like Geechee or somebody over here said.
Good job, Geechee.
And then f of x over g of x would be what? Perfect. Are we going to cancel here? No, we are not, because this is just like the ones we talked about before. If you want to cancel in a 3-part problem, you got to cancel out of every part. You can't just cancel out a part of the parts. So that's done. What is the domain of all of these answers? So here's A, B, C, D, and E. All right, so here's A. What is the domain of that? All reals. Very good, Tag. And why is it all reals? No radical, no fraction. Those are the 2 things that cause me problems. All right, what's the domain here? All reals. No fraction, no radical. What's my domain here?
All reals.
All reals, no fraction, no radicals. How about here? All reals, no fraction, no radical. How about here? X cannot be 0. Your domain is x cannot be 0. Why? We got a fraction. And what do we know about fractions? Denominators cannot be 0. So x can't be 0 is your domain for this one. Okay? Now we're switching, same functions, we're using the same functions, but now we're switching to what is called composition. Now we are going to evaluate f of g of 2. Let me say that again. F of g of 2. And you did this last year. Do you remember how? Do you remember anything about it? Kelly Berry, you answering the question, scratching your head? Can you answer the question? I plugged the 2 into G. Very, very good. This says f of g of 2. So we're going to find g of 2 by plugging 2 in. So what is g of 2? 4. So now what the problem really says is find f of 4, because this is 4. So it says find f of 4. And what is f of 4? 6. And that's the answer to the question. So we plug 2 into G and get an answer. And then take that answer and plug it into F, and that's the final answer. this problem H is exactly the same problem. It is written differently, but they are the same problem. Do you remember that notation from last year, that little open circle? Both of these say exactly the same thing. F of G of 2. So the answer to this one is also 6. It's the same problem. You put 2 into G and the answer into F. It's just two different ways of writing the exact same problem. Right? Okay. Now, what about I? What's I telling me to do? Plug 2 into F. And when I plug 2 into F, I get 4. And then I'm going to take that 4 and plug it into G and get 16. That's the answer to the question. So once again, 2 goes into F, you get an answer. The answer goes into G, and you get the final answer. That's pretty easy, isn't it? Do H of F of -1 on your own. That's problem J. H of F of -1. I got 3. Did you get 3?
Yeah.
Because when you put -1 into F, you got 1, and then you put 1 into H, and you got 3. Oh my gosh, look at K. F of G of H of 1. Oh my gosh. Lucas, you got a thought on that? How we might start that? I'm going to put 1 somewhere. Where do you think I'm going to put 1? Yeah, remember, let's read it. Find F of G of H of 1. So you're finding H of 1 first. And so H of 1 would be 3. So this part, Lucas, equals 3. So now it says, find F of G of 3. So what am I going to do with the 3? Put it into G. And G of 3 is 9. Now what am I going to do with the 9?
Put it into +2.
Put it into F. And so my final answer is 11. All right, there were more steps to that one. Let's talk about it, make sure everybody's got it. F of G of H of 1. So we go this way. So we plug 1 into H and get the answer. We take that answer and plug it into G. Get another answer. Take that answer and plug it into F. That's the final answer because I'm out of letters, right? So 11. What's different about L? There's no number. There's no number. So what does that mean, that there's no number? Well, this says find F of G of X. There's no number. What's G of X? What is G of X? X squared. So what we're really doing is finding F of X squared. Now don't be worried. If I said find F of 7, you would come up here and put 7 right here, right? If I said find f of 12, you would put 12 right here. So when I say find f of x squared, don't panic, put x squared right here, just like you would a number. So our answer is just x squared plus 2. Instead of having a number, you have some algebra. You have x squared. You just put x squared the same place you would put the number. One more. H of f of x. All right, h of f of x. What's f of x?
X plus 2.
X plus 2. So I'm finding h of x plus 2. That means that I go to my h function, and where I would have put in a number, like if it said h of 5, I would put in 5. Where I would have put in the number, instead I'm going to put in x plus 2. So I'm going to end up with negative 2 times x plus 2 plus 5. Instead of plugging in a number, I'm plugging in an algebra. If I said h of 10, you would put a 10 right there. If I say h of x plus 2, you put an x plus 2 right there. So your final answer is negative 2x plus 1. All right, we're going to go ahead and wrap it up. We're going to do our implicit functions because they're very easy. One more thing to do, implicit functions. Here we go. Very easy to do. To find the implicit functions, and what we mean by that is, this is not a function. If you graphed that, anybody know what it would be? X squared plus y squared, what shape that would be? Circle. Centered at the origin with a radius of 2. That is not a function. Why? Why is that not a function? Doesn't pass the vertical line test. So if you wanted to graph this, let's say on your calculator, you couldn't do it. The calculator doesn't graph things that aren't functions. So if we really need functions, we're going to split this equation up into 2 smaller pieces that are functions. We're going to split this up and look at the top half of the circle and the bottom half of the circle separately. Now, is the top half a function?
Yeah.
Is the bottom half a function?
Yeah.
Oh, so then if I could graph the top half and the bottom half together at the same time, I'd get my circle. These are going to be the implied or the implicit functions. To find them, it is so easy. Get y by itself. Just solve for y. So the first thing I'll do is subtract the x squared. I'm getting y by itself, so I'm going to move the x squared over. Now I have y squared by itself, so to get plain y, I will take the square root, remembering the plus or the minus. The plus is going to be the top half of my circle, and the minus is going to be the bottom half. These are your implicit functions. The square root of 4 minus x squared and negative the square root of 4 minus x squared. Do not Try to simplify that. You're done. Don't try to take the square root of the individual pieces. It's not right. You'll get the wrong answer. Just stop. After you've taken the square root, stop. These are your two implicit functions. Let's look at B. You're going to do exactly the same thing. Anytime it says find the implicit functions, you're going to get y by itself. So what will we do first? This is question B. What will we do first to get y by itself? We're going to subtract 2x. And then take the square root. And when I take the square root, I can't forget plus or minus. Because remember, I'm breaking this up into two equations. One is the square root of 8 minus 2x. The other one is negative the square root of 8 minus 2x. No, no, no. Do not do anything. We are done. You cannot simplify these. Try C on your own. Find the implicit functions for problem C. Remember what that means is get y by itself. Get y by itself. And if you get C done, try D. Do you have C done? You match me? These are my implicit functions right here. Everybody okay with that? Girls back there, are you okay with this? Everybody good? All right, have you gotten this one done yet? Remember, you're solving for y. This one's a little trickier. This one has a fraction in it, but I'm not going to panic. We going to cancel that negative and that negative? No, they're separated by radicals. You can't do anything. Again, you take the square root and you are done.
It's the same if it's 1 over 4x.
Yes. Oh, be careful. It wouldn't be 1 over 4x. That would not be the same.
Oh, no, like 1
But
over 4.
1/4
And
x
yeah.
would be fine. Yes, 1/4 x is fine. All right, how are we there? Guess what we just did? We just finished. 1, 3, and 1, 4. Homework. Homework will be due Wednesday. We will be having a test. No,
Friday.
no, it won't be until at least Tuesday of the following week. Because we don't have classes Thursday and Friday.
Are you wrapping PowerPoint then?
Uh-huh.
We have to have a little bit better.
I'll see you there.
Yes, I am.
I don't know what, I don't know.
You're spiding on the ball before the birth of better.
You know what? I think I spot right. I think Mrs. Bamber, she always
We got a naughty girl in here.
gives,
You want me to stop this, Miss Ford?
okay.
Miss Ford.
All right, listen.